Okay, now I'm going to expand our thinking here. So far we've been doing pyramid numbers. So before, when we went up, it was multiply. Now this way, if we go down, it's add. So 3 plus 4 is 7, is the code. Okay, so what's the missing number now? So let's call that together. I'll say 1, 2, 3. 1, 2, 3. 22. So we're doing this in a sort of a slightly different way. Okay. So what might be those missing numbers now? So you can see now we've got a slightly different experience of what those numbers might be. Now you're probably saying so far, oh, this looks like a grade 3 thing or something. And it vaguely is so far. But okay, what if we start lifting the game a little bit? And what I'm talking about here is just an idea that we no longer need to explain this to the kids because we've done it every day for the last 10 days or something. We've had a range of different experiences. And so we can actually sort of go on. Okay. Now we're going plus, going upwards. What might the numbers be on the top line, but the numbers have to all be different. So can you work out that one? Okay, so what are some numbers on the top line? 8, 5, 6. 16, 2, 3. Someone actually took my whiteboard. I was actually going to write all these down because this is part of the nice thing. So another one? 7, 8, 9. Another one? No, I don't think 7, 8, 9 will be it. Really? Because see, what we've got to do is got to break that up into two numbers in that. 5 and 8 is 13. 13 and 11. Yeah, so 8, 5, 6, yeah. Okay, like that. So what's another one? Say that again. 11, 5 and 3. 17, 1 and 5. Another one? 6, 4, 10. Okay, so then we've still got a whole bunch of other answers we could do, but we'll just keep going. But that would be part of the experience for the kids, just realising, oh, they can come up with their own answer, because there's almost enough answers, even for something as simple as that, for everyone in their class to have their own, to do that. Okay, now, so far we've been doing just pretty straightforward stuff. What I want you to think about is this, that we can actually now set it up like this, where if we have 3 and 4 there, then 3 and 4 is 7 there, but 3 times 4 is 12. So that's the code that we might be using here. Okay, what might be those missing numbers? So 9 and 2, you're happy that 9 and 2? Okay. What might be the numbers? Just tell me the number at the top. What might be the number at the top? Please, can you work out as many different answers as you can? So, what are the numbers at the top? What are some possibilities?
10, 11, 24, 21, 30.
So, gee, wow. So, 10, 11. Sorry, did you say 11? How do you get 11?
2 plus 4.
So 18, yeah. 24, 28, 30. Are there others? 0. Excellent answer. Could anyone prove that there's no more answers, do you think? You know, unless you can prove there's no more answers, you get voted off survivor, classroom survivor or something.
I think probably a good question would be to ask kids how many combinations are there and how do you determine exactly that question?
Yeah.
The number, and that would be the two numbers that make up 11. There's a limited set of those.
Yeah. Yeah. So we're going to keep, but I think that you can see that this question is different to the previous one, which is different to the one before, which is different to the one before. Now we could do another one of these tomorrow. As I say, you know, just doing them for a couple of minutes at the start of the class. So tomorrow we might have 13 there or something. So it doesn't, we don't need to, okay. What might be the numbers at the top now? The people at the front here are saying, oh, there's an infinite number of answers, which is probably true, but what I would say is I want to start to describe. But let's just say some of the basic answers. What are some of the answers for this question? Sorry, what? Yeah, simplified answer, always the simplified answer. So 2 over 25, 21 over 100. 6 over 25. 1 over 5. 7 over 50. 9 over 50. So it would actually be interesting, could you see, if we had a whiteboard, we started to write these up, and maybe if we wrote them in order, the answers, would we get a pattern? Would we have ways of actually trying to describe these answers? What do you notice about all of those answers? I mean, one of the things you might notice that they're all less than 9/10. How could that be if we're multiplying? So, you know, so we actually get, can you see how now we're getting a whole different experience from just what's basically a trivial idea of how you present questions? All right, now just to make the point, I quite like how different this one is. Can you do this one now? Can you see the sort of thing? This is the sort of thing, by the way, that you could actually do with Year 11 kids to do that. I was watching a lesson just yesterday. It was on, turning points, stationary points, and so on, with calculus that the kids were doing. It was getting near the end of Year 11, and the point was, it's really easy to find, you know, to differentiate a quadratic function and to find the turning points of the zero. Really easy. Except if you get fractions. And then it's really hard. So, well, for the Year 11 kids, it's really hard. So what the real thing is that when they get to calculus, the only thing that's hard about calculus is the fractions. So even Year 11 kids, we've got to actually get fluency with the, oh, actually I should have actually had directed numbers when that comes in too, but the thing is that even the Year 10 and Year 11 need to get some bit of fluency with this sort of stuff, that they start to become familiar with fractions and they can operate. And the reason I showed you the mixed number is because it behaves in a different way to just the common fraction to do that. Okay, here's another one. Do this one, please. All the possible answers. You might like to write these in order as well, the possible answers. Even though this looks like a really trivial question, we're now talking about serious maths. When we start to say, well, okay, how can we describe the answers? Okay, what's possibilities for the top?